For us, self-proclaimed technologically advanced creatures, humans of the past may seem incredibly primitive compared to us. An enormous technological gap almost distinguishes us as a new species, and just a few hundred years was enough to make that happen. We think that because human curiosity has no boundaries, our intellectual progress has none either. The truth is, our progress is minuscule on a galactic scale. But how advanced could the human race become? And how long will it take to become super advanced? Do great cosmic voids point to a hyper-intelligent extraterrestrial life? And how far advanced would those alien civilizations be? Get ready to discover the answers to this and more. We've created the internet, landed on the moon, discovered the Higgs boson, and our spacecraft have entered interstellar space. It seems that in the past 100 years, we've accomplished more than we could ever think of, and it's difficult to imagine that we could go any further. But what if that's just the tip of an iceberg? What if all human progress is nothing but our collective illusion? Over time, the Kardashev Scale of a civilization's technological advancement has expanded and narrowed. One of the ideas is that there are 4 levels of civilizations in the Kardashev Scale. Type 1 civilization, or a planetary civilization, would be capable of harvesting all the energy resources available on its planet. Type 2 civilization, or a stellar civilization, would go further, being able to harness the energy of an entire star, basically allowing it to control a whole planetary system. A Type 3 civilization, or a galactic civilization, could utilize the energy resources of an entire galaxy, move planets, and feed black holes with stars. But even that's far from what a Type 4 civilization would be capable of, creating a universe itself. And according to this scale, we haven't reached Type 1 civilization status, but we're not a Type 0 civilization anymore. So, where does this leave us then? 0 on this scale signifies a specific amount of energy consumed by a civilization, which is roughly 1 megawatt of power. Currently, our average annual energy consumption is roughly 17.7 terawatts. And just a single terawatt would be enough to power 10 billion 100-watt light bulbs simultaneously. Human beings have a score of about 0.73 on the Kardashev scale. But how fast can we reach the milestone of Type 1 civilization? One famous theoretical physicist has estimated that if we increase energy consumption by 3% yearly, it would take 100 to 200 years to get there. As for now, about 1 billionth of our star's energy reaches Earth, and we only use 1 millionth of that. Once we achieve this status, we'd be able to utilize all the sunlight, wind, and tides available to us. Weather conditions would be controlled by our will, and we'd be able to alter the course of earthquakes and volcanoes and make floating cities on the water. All this sounds like we'd have superpowers, but that's nothing compared to what civilizations of Type 2 is capable of. Also called a stellar civilization, it would go far beyond harnessing energy from its home planet. At this level, intellectual creatures could control their entire parent star's energy output, and there are several ways to do it. One idea is to use a megastructure called a Dyson Sphere. Its simplified version, a Dyson ring, would consist of a bunch of solar power collectors encircling a star at, for example, about 160 million kilometers. And as this civilization continues to advance its technologies, it would add more rings around a star, each having its own orbit. Eventually, this megastructure, the size of our planet's orbit around the Sun, would resemble some type of a shell encompassing a star, blocking most of its light, but also collecting most of its energy. For us, the creation of such a technology would mean nearly the same as the invention of electricity. Starlifting is yet another method to steal some energy from a star, but how exactly does it work? A highly intelligent civilization midway to Type 3 civilization would possibly know how to siphon material from a star and put it into a spinning black hole's ergosphere. The ergosphere is a region surrounding a black hole outside its event horizon, and lots of fascinating phenomena happen there. By sending material into this region around a black hole, you could get energy back out at much higher speeds. This is called the Penrose process, and according to this, roughly 29% of the energy in a black hole could be extracted. But there's also a downside to this method. A black hole will start spinning slower and eventually it will stop. However, this also opens another possibility: harnessing Hawking radiation from evaporating black holes, which is far beyond our capabilities. But it would hardly be rocket science for a Type 3 civilization. This galactic-level civilization would essentially use the same technology as a previous one, but at much, much larger scales. We're talking galactic scales. Entire galaxies would be filled with Dyson Spheres surrounding billions of stars. New planetary systems would be artificially made. Their supplies of energy would be infinite. They would practically become immortal. And the only thing that would threaten their existence would be a sudden natural catastrophe, such as the massive explosion of a supernova. For humans, at least 100,000 years are needed to become as advanced. And it could even take 1 million years to become a Type 3 civilization if we ever survive long enough. But do such civilizations exist? And if so, such an intense technological activity would be easily observable in space. According to NASA, we found about 4,000 planets outside our solar system in the past 2 decades. And in the Milky Way alone, there should be trillions of stars accompanied by planets. So why haven't we found any signs yet? This is called the Fermi paradox, and it says that our universe is too old and too large for there not to even be a single other life except for the one we have on Earth. But throughout decades, we haven't found anything like that. But we may not have looked hard enough. The ongoing search for extraterrestrial intelligence is limited to catching several frequencies of radio and TV emissions. The problem is, such signals could only be made by a Type 0 civilization. And because they also interfere with static charges in space, a good portion of that signal is lost. A much more effective way would be to break signals into all frequencies to preserve most of that signal. Sadly, a hypothetical Type 0 civilization using only one frequency wouldn't be able to read that message fully, hearing nonsense instead. So even if the Milky Way is loaded with a variety of messages from Type 2 or Type 3 civilizations, human Type 0 radio telescopes cannot hear them properly. Another researcher at the National Astronomical Observatory of China came up with a new theory of where those civilizations could be hiding. A professor and her team scanned a significant portion of the sky and detected 21 galaxies. They were searching for unusual radio signals to detect alien exhaust, and the 2 weird galaxies they've discovered had enhanced infrared emissions that couldn't be explained by natural phenomena. Astronomers hope it could point to a bunch of Dyson Spheres and entire galaxies captured by an intelligent civilization or civilizations. But to prove the idea, they need to know for sure what's causing these infrared emissions. There's also another solution to the Fermi paradox. Perhaps these civilizations have decided to stay unnoticed. Our universe is vast, and just because we haven't succeeded in finding anyone doesn't mean they're not there. When looking for signs of technologically advanced civilization, astronomers often base their observations on different types of infrared emissions and waste. But what if a superintelligent civilization has not only come up with unimaginable technologies, but also found a way to hide its presence? If so, all this time, we've been searching for something we shouldn't and neglected what demands our utmost attention. If we continuously fail at finding any signs of extraterrestrial civilization, we could try studying what's missing instead. Because the most likely scenario is, if a Type 3 civilization existed somewhere out there, it would gather all the energy available in a galaxy and exhaust all its power supply, leaving nothing behind. And there are such empty regions in space, the Great Voids, which were once believed to be signatures of intelligent life, but this theory was refuted. And although scientists haven't lost hope, most of their studies eventually come to a dead end. And if that's always the case, there arises another question. What if we just came to be at the wrong time? According to one computer simulation, intelligent life could have been more abundant 4 billion years ago than at any other moment. It may seem unbelievable, but if primitive life existed on Earth roughly 3.5 billion years ago, why couldn't intelligent life exist elsewhere in the universe at about the same time? And should we even try so hard to satisfy our natural curiosity with the threat of possible extermination of human beings as a species? We all come from one ancestor, and we cannot restrain our anger towards each other. So, should we think that a hyper-advanced civilization would care more for our lives than we do? Today we're scared of exhausting our planet's resources. Type 2 civilization would be afraid of the death of their star, and Type 3 civilizations would be concerned about how to escape the death of the universe. But if we look at the broader version of the Kardashev Scale, for a Type 4 or even Type 5 civilization, even that wouldn't be something to worry about. These creatures could theoretically form a new universe. And according to one physicist, the energy needed to give birth to a baby universe in a laboratory would require about 1,000 trillion degrees, which is far below the limit of such a civilization's capabilities. Although Type 4 civilization is hardly ever achievable, it would literally mean becoming the creators of everything we could ever observe, think, or imagine. Given how fast we evolve, and that even today the creation of effective tiny laser-propelled spacecraft are within our arm's reach, it could be true that we've already been visited in the past, and the odds of noticing their presence almost equal zero. Even now, we may be observed by a much more advanced civilization that just waits till we make enough progress to eventually get in contact. Or maybe they've already decided to reach out, but it will take hundreds of thousands of years till they arrive here from another galaxy at the other corner of the universe. But even if we don't find anybody, it doesn't necessarily mean a bad thing. Sure, we would feel lonely and maybe even abandoned, but this would also mean that we have the chance to set the foundation for the future stages of human evolution. One day, those hyper-intelligent creatures, somewhat resembling us in appearance, could think of us as pioneers, explorers, blindly discovering this dark place we were put in as a child discovers the world. Maybe it's all our imagination that makes us think they exist, and maybe they do. But it's not them, it's us. Future us. Superhuman beings.